All right, so first we're going to practice synthetic division. Then I'll talk about this question. This question is telling you to use the remainder theorem. You're like, what the heck is that? I'm going to tell you what that is in a second. But first, let's pretend we're dividing this guy by this. Now, if we were doing that, we would say the 0 for this is -2, which is actually written right underneath it, right? Okay, so you write out first the leading or the coefficients for each of those terms. So we get 3, 8, 5, and -7. And then I mean, this is my style. That's why I like to do it. That's my remainder. Okay, and then I'm going to put -2 right here. All right, that's my 0. You guys ready to do this now? You bring down the 3, then you multiply it times -2, you get -6. And so we went 3 times -2. That's how we got this new number. Now we're going to add those. We always bring down the first number. So then we get a 2, and then when I go 2 times -2 is -4, so I write that right there. And then what's my next number? 1. And then 1 times -2, what does that give us? -2. And if I add those, what do I get? -9. And so -9 is your constant. I'm sorry, no. -9 is your remainder, so I go minus 9 over x plus 2, because that's what we're dividing by, right? Okay, and then this is our constant. 1 is our constant, and then we have the x term, so we get 2x, then we have our x squared term. So this is the answer if you're just dividing. Okay, but that's if you're just dividing. This problem is saying use the remainder theorem. Okay, what is that? Well, do you guys remember what evaluate means? That means like we're going to take this -2 right here, and we're going to plug it into that f of x. So I'm going to go f of -2, and that means 3, and I plug in -2 right here. I have to raise it to the third power, plus 8. I plug in -2 right here. I raise it to the second power, plus 5 times -2, and then minus 7. You guys with me? Yeah. That's what evaluate means. It means you're plugging it into the function. But watch the magic. So this is really cool. I hope you guys see it really fast. Okay, what is -2 raised to the third power? 8. That's this one. -8, right? -8, because -2 times -2 is a positive 4. Positive 4 times -2 is -8. Yeah? Okay. So -8 times 3? -24? Yeah. I almost wrote 32. Don't make fun of me. All right, -2 times -2 is 4. 4 times 8 is? 32. And then I have a -10 from this guy, right? And then we have -7. Oh, man, look at all this arithmetic we got to do. I'll add our negatives together. That's -34. And, oh, dang it, I forgot the 7. Okay, -34, -7, that's -41, right? Yeah. Plus 32, because that's positive, so we have to subtract those. What is that? That's 8 and then 9, positive, -9, right? Oh, what do you guys notice?
Wow.
Okay, this is remainder theorem. Remainder theorem just simply says if you do synthetic division, it's the same as plugging it in. Whatever your remainder is, that's your answer. So instead of doing this, I can do this and get my answer. Does that, you guys see?
So you just skip remainder?
No. That's if it says, hey, plug in -2 to this. You're like, I'm not going to plug it in. I'm going to do synthetic division, and whatever my remainder is, that's my answer.
But that's all you need.
That one's easier.
Which one do you think is easier? This one?
Yeah.
The one you're familiar with?
Yeah.
And therein lies the reason why you can't teach old dogs new tricks.
Wait.
Oh, okay, be honest. Like, who's going to win? The person that uses synthetic division or the person that does this?
Synthetic division.
Let's find out. You guys have a competition with each other. I want you guys to plug in 5.
This one?
So you guys are doing this. You guys are going f of 5.
Even synthetic division is pretty big.
Synthetic division still stinky?
Yeah.
What do you get?
25.
You're like, numbers too big. Okay. So if I go 5, and then I go 3, 8, 5, -7. I bring down the 3 first, and then I go 5 times 3 is 15, and I add those, I get 23. 23 times 5 is 115. And if I add those, I get 120. 120 times 5 is going to be 600. Is that right? Yeah, 600.
How are you doing that? What?
Oh, because I ignore the 0. What's 12 times 5?
60.
60. And you put the 0 onto it.
23 times 5. That's.
Oh, because 20 times 5 is 100. And then 3 times 5 is 15. Okay, and then I add those, I get 593. That wasn't too hard.
I got that.
Yeah, 593. And now if you're doing it the other way, that way sucks. Because you have to raise 5 to the third power and multiply that number times 3.
That's not hard.
No, shut up! My way's better! No, I'm joking. Go remainder theorem!